Welcome to the channel Professor Davinci. I am the professor. Subscribe and hit the bell icon to stay updated.
Let us see another exercise. Exercise 2.1a 1c. You need to find the relation h of x equals the root x plus 1, where x belongs to the real number. So we need to find the relation. So to find the relation, we need to have an input value, that is a domain. As I said earlier, let us take the domain -2, -1, 0, 1, 2, right? So here h of -2 equals root of -2 plus 1 equals root -1. So whenever you have a root, negative value under the root, that is the imaginary number. So I root of -1, that is the imaginary, this is the imaginary value. Whenever the negative value, negative number comes under the root, that is the imaginary. So you might have studied about the complex number, real part and the imaginary part. So this is their imaginary part. Whenever the negative value comes under the root, is the imaginary. Then h of -1 equals root of -1 plus 1, again root of 0. H of 0 equals root of 0 plus 1 equal to root 1 equals 1. Then h of 1 equals root of, then h of -1 equal to 1 plus 1, h of 1 equal to 1 plus 1, so it is a root 2. So root 2 has some value, that is not more important here. H of 2 equals 2 plus 1 equals root 3. So here if you see, whenever the h value goes less than -1, so it produces the negative value of under the root, that is the imaginary value. So whenever the h the domain x is -1 greater than or equal to -1, it produces the real value. So here we can say that h of x represents the square root. So here, so h of x represents the square root function, as long as the term inside the term, as long as the term x plus 1 is greater than or equal to 0. As long as the term is greater than or equal to 0, then that exists one-to-one relation. If the term, if suppose for example x plus 1 is less than 0, suppose here x plus 1 is less than 0, here from here and above, this is x plus 1 is greater than or equal to 0, okay, it produces this all is called one-to-one relation. So this from here onwards, whenever x plus 1 is less than 0, that exists, that is I said it is a real number. So there is no real roots, no real roots are available, no real roots or no real output or no real codomain is available. So that is not under the function. So whenever h plus 1 term is equal to 0, then the term obeys the rules of the function and it's a one-to-one relation, right? Okay, right. So to be clear in this, we will solve another example. Let's say 3c. for the function associated domain state the range. So we need to find the range. So 3c, find the range. Find the range for h of x equals x minus 1 whole square, where x belongs to the real number. So here also we need to find the range. So for the range we need to assume here domain. Assume here domain equals -2, -1, 0, 1 and 2. So h of x equals -2 minus 1 the whole square equals -3 square, 3 3s are 9. H of, sorry, this is h of -2, this is -2. H of -1 equals -1 minus 1 the whole square equals 4. H of 0 equals 0 minus 1 the whole square equals 1. H of 1 equals 1 minus 1 the whole square equals 0. H of 2 equals 2 minus 1 the whole square equals 1. So hence the range equals number of possible outputs. The set of number of possible outputs is called the range. So as I said, we should not repeat these numbers again. So 9410. So here is the range. Okay, got it? See you, bye bye. Have a great day.